Today we will talk about the photoelectric effect. And initially, the photoelectric effect was discovered by Hertz while he was studying and working on the cathode ray tube. Remember what we said about cathode ray tube, finding the charge to mass ratio. And while he was working with the cathode ray tube, he discovered that if we have a vacuum chamber like this one here, this is the vacuum chamber. And chamber, and one of those plates is worked with special material. As soon as the light ray was collided into that special wearing that one of the plates on the parallel plates had, he noticed that sometimes the electrons were going and were hitting the other plate, and he noticed that there was an indication of the intensity of the light, which means that the electrons are hitting the other plate. So while he was studying it, he discovered some of the characteristics that the photoelectric effect had. So first of all, and this was like he was amazed, that the substances shows a photoelectric effect only if the incident ray, the light that was hitting the plate, had a unique frequency. So each plate, when he was changing the plate, the electrons were or were not able to reach the other plate on the vacuum chamber. Okay, so this frequency, he called it as a threshold frequency. So what he noticed that, let's say, zinc will emit electrons for violet light, but not for blue light. Okay, so it was a specific frequency that if it was if the incident ray was lower than that specific frequency, then the emission of the electrons will not show. Okay, any frequency that is below the threshold frequency will not produce any photoelectric, any motion of the electrons. Okay, and different materials have a different threshold frequency. So once the external light is at the above minimum, the photoelectric effect is instantaneously. So you don't have any time delay as the light is hitting the plate and the circuit is closed, which means that the electrons are flowing and you notice an intensity of the current. And as you increase the frequency of the incident light, you do not notice any effect on the current flow. Let's say that if the frequency frequency does not affect the number of electrons being emitted. However, the increase of the intensity, which is the amount of light that is entering per minute of time, the increase of intensity of the external light will increase the amount of photoelectric effect. And very often this is called as the photocurrent. And lastly, discovered that increasing the frequency of the incident array will cause the kinetic energy of the photoelectrons to increase. In other words, the speed of the electrons is increased with high energy light. So not the fact that the electrons are moving, but the kinetic energy of the electron. All those findings of Hertz, those are Hertz findings through the photoelectric effect are listed here, and pretty much are what we said. And all those we were not able to explain through the classic physics point of view. So that means that now we enter into something that is known as the quantum physics point of view. Remember what Hertz said, that in order to explain the black body radiation, is the previous video, in order to explain the black body radiation, you have to consider light as a bundle of tiny massless particle without that carries energy. So no mass, but able to carry energy. And remember, this was a breakthrough in physics, because every time that we have discussed about the energy, we have said that the energy is a scalar quantity, and it is a mass, an object that has a mass, and it's either moving or it's able to potentially possess certain energy, either kinetic energy, or sorry, gravitational potential energy, electric potential energy, and so on and so forth. And when I told you when not Hertz, but when Planck presented that theory, he even said that this is something that classical theory is not able to explain. However, let's keep this until we find next. Let's keep this theory until we find a way to explain it using classical physics. However, Albert Einstein, which in school he was not particularly brilliant, and he didn't like the German school at that time. He dropped school from Germany and he went to Switzerland, where he was graduated from Polytechnic school in early 19s. And then he was working, but while he was working in a very meaningless job, he was working on the world of physics, and very early he published 3 papers. The first paper was the mathematics that is associated with something known as the Brownian motion. The second paper was about photoelectric effect, and the third one was the relativity, special relativity. Any of those papers will be worth of the Nobel Prize. However, Einstein, like Maxwell, was a theoretical genius. So in order to confirm his theoretical results, he needed an experiment. Okay, and then just for his contribution, because he actually didn't do anything, didn't go through formal schooling to get his PhD, but just because of his contribution, the PhD was granted. And then in 1915, Einstein published another major paper on general relativity. And then very soon after that, he left Germany because Nazi was in power, and then he moved to Princeton in the United States. Einstein, what he did, he took the Planck's theory, borrowed, quote unquote, Planck's theory and was able to explain the photoelectric effect. So remember what we said about Planck, that uh, any photon uh, or a bundle of energy that doesn't have a mass has an energy that is calculated as h times f, or h times c over lambda. In Einstein's explanation, he assumed that the electrons on the surface of the metal were held with a certain amount of binding energy. For the electrons to become free of the metal, this binding energy has to overcome. Einstein called the energy required to overcome the binding energy as the work function. Okay, work function is like, you need to remove the electron from the structure that they are. And we know now work and energy are the same, the work and energy principle. Further, Hertz had discovered that light below the threshold frequency will not free any electrons. Okay, so now the frequency of the light that had to be at or above the threshold frequency is using the work function, the concept of work function that Einstein represented, and the Planck theory. He said that this work function is Planck's constant times the threshold frequency. If the photon with threshold frequency strikes an atom of a metal, that the electron will be freed immediately. This is no time delay. Then Einstein was able to explain both the threshold frequency requirement and the instantaneous flow aspect of the photoelectric effect. So there is no need to heat it. In addition, Einstein's model implies that if you increase the number of photons striking the metal surface, which is the intensity of the light, because the intensity of the light is the number of photons, the amount of light entering per unit of time. So if you increase the number of photons that are striking the metal surface, then, which means increase the intensity, then more electrons will be removed from the binding energy that the electrons have on the surface of the metal. So an increase on intensity produces a greater photocurrent, which is one of the findings that Hertz had. So with this model, he was able to explain even this. Also, with Einstein's model, we were able to explain the increase in kinetic energy of the electrons as you increase the frequency of the intensity of the current. So if the frequency of the intensity of the current is greater than that minimum energy, the work energy, to remove the electron from the original structure to overcome the binding energy that the electrons have, any excess will go into kinetic energy of the electron. So will transform into kinetic energy of the electron. So therefore, with the explanation of Einstein, photoelectric effect is explained using the conservation law of energy. And the genesis of Einstein beside all the other things that he had contributed into society, that he was very simple and very basic on the explanation. So the kinetic energy of the electron, okay, is equal to the energy of the photon minus work function. Or, in other words, the energy of photon is equal to the kinetic energy of the electron plus work function. Okay, so if a threshold frequency requires now an example, if the threshold frequency requires an emission of the electron is 4.0 times 10 to the power of 14 hertz. What is the work function in joules and electron volts? Remember what we talked about, electron volts. Then what do we do is work is equal to H times FO, which if we are calculating it in joules, so then we will use 6.63 times 10 to the power of negative 34 times 4.0 times 10 to the power of 14 hertz. Then the work function of this particular surface in joules will be 10 to the power of negative 19 joules. And if we are calculating it in electron volts, then again, H is equal, work function is H times FO, which now we will use the Planck's constant for electron volt. That is 4.14 times 10 to the power of negative 15, I think, times 10 to the power, or times 4.0 times 10 to the power of 14. And this will be, let me grab my cup. It was 4.15 and not 4.14 times 10 to the power. So this will be 1.66 electron volts. So depend on what you are looking, what units you are looking for. If you are looking for joules, then use the 6.63, and if you are looking for electron volts, then use 4.14. Okay, so again, the explanation of the photoelectric effect is based on the conservation law of energy. If the work function, so now let's see another example. If the work function of a metal, and each metal have a specific, a unique work function because it has a unique configuration of the electrons, which makes the binding energy of the electrons in the atom a unique one. So if a work function of a particular metal is 3.52 times 10 to the power of negative 19 joules, and it is illuminated by light with a wavelength of 565 nanometers, what is the speed of the escaping electrons? So what is the velocity or the speed of the escaping electrons? Okay, the photoelectric effect is explained with the conservation law of energy. So as the photon is collided with the electron, then all the energy that photon has is given to the electron. Conservation, so there is no loss of energy there. And the electron is using this energy that photon is giving to remove itself from the binding energy work function, and then to gain some speed to move to the other plate of the photoelectric effect. So the energy of one photon is equal to the kinetic energy of the electron plus work function. Now, the energy of the photon based on Planck's on Planck's theory, and since we know the wavelength is hc over lambda is equal to work function is given as 3.52 times 10 to the power of negative 19 plus kinetic energy of the electron. So therefore, from here, we can say that the kinetic energy of the electron will be equal to Planck's constant, which is, now we are working, work is given in joules. And every time that you're looking for the speed of the electron, you have to use, even if it is given in electron volts, you have to use joules. So this will be 6.63 times 10 to the power of negative 34 times speed of light 3.0 times 10 to the power of 8 over the wavelength, so that is 565 times 10 to the power of negative 9 to convert it into meters, okay, minus the work function, that is 3.52 times 10 to the power of negative 19 joules. And if this work function was given into electron volts, then convert it into joules, because the units for the kinetic energy has to be in joules. Okay, so let's plot this into the calculator and see what do we have for kinetic energy. For kinetic energy of the electron, I have 3.54 times 10 to the power of negative 23 joules. Now, on the other hand, what we know is that the electrons are particles, like objects with a mass that are moving. Therefore, the kinetic energy is 1/2 mass of the electron over v squared. And so from here, the speed of the electron will be the square root of 2 times kinetic energy of the electron over mass of the electron. And in this case will be the square root of 2 times 3.54 times 10 to the power of negative 23 over 9.11 times 10 to the power of negative 31. And now using your calculator, let's see what is the speed of the electron. And I have here for the speed of the electron as 8.82 times 10 to the power of 3 meters per second. So this is the speed that the electrons are going from one plate with that specific work function into another one, into the other one, and on that case closing the circle. Okay, let's take a look at another example. A metal surface has a work function of, so work function is 2.05 electron volts. If the fastest photoelectron emitted from this plate is with a speed of, let's say, 3.82 times 10 to the power of 6 meters per second, what is the frequency? And then later on, let's find the wavelength. Just to review, how do we find the wavelength of an EMR? Okay, so now this is a photoelectric effect. We do know that it's a photoelectric effect because it's saying that it's the photoelectron emitted, okay? And it is explaining that this is a photoelectric effect. So now, photoelectric effect is explained using the conservation law of energy, okay? Question on the diploma, what principle is photoelectric effect using? Which is saying that the energy of the photon is equal to the work function plus the kinetic energy of the electron. Okay, based on Planck's theory, the energy of the photon is Planck's constant times frequency, or Planck's constant times c over wavelength. But in this case, since we are first looking for frequency, let's use this, is equal to work plus kinetic energy of the electron. So we are looking for a frequency, and the frequency will be work plus kinetic energy of the electron over Planck's constant. Now let's substitute. What do we have here? We have that the work function is 2.05 electron volts. Okay. On this case, we should, again, since the kinetic energy is involved on it, we should convert the work function into the from the electron volts into joules. So now the kinetic energy of the or work function is 2.05 times, that is in electron volts, times 1.60 times 10 to the power of negative 19 to convert it into joules, plus 0.5 times mass of the electron, 9.11 times 10 to the power of negative 31 times, let's rewrite this in a better area. So we'll have the work function converted into joules, multiplied it by 1.60 times 10 to the negative 19, and then kinetic energy of the electron, 1/2 or 0.5 times 9.81 times 10 to the power of negative 31 times the speed, mv squared over r. So 1/2 mv squared over r. And then from here we find that the frequency will be, using your calculator. In my calculator, I have 1.05 times 10 to the power of 16 hertz. And now if we are looking for the wavelength, then we will use the general equation of the waves, which is saying that frequency times wavelength is equal to speed, which in our case, since we are dealing with the EMR or light, is equal to the speed of light. And from here we find that lambda or is equal to c over frequency, and this will be 3.0 times 10 to the power of 8 over 1.05 times 10 to the power of 16, and this will be 2.85 times 10 to the power of negative 8 meters as the wavelength of this particular light. Okay. If a metal surface has a threshold frequency of let's say 5.0 times 10 to the power of 14 hertz, what is the kinetic energy of the escaping photoelectrons when the light with a frequency of, let's say, 7.22 times 10 to the power of 14 hertz strikes the surface? Okay, so what is the just kinetic energy? Okay, kinetic energy of the electrons, and then we can go even further to find the speed of the electrons. Okay, again, photoelectric effect is explained with the principle of conservation law of energy, which is saying that the energy of the photon is equal to the work function plus the kinetic energy of the electron. One thing that we have to emphasize here is that photons and electrons have a very unique relationship. So if photon is, or when photon is striking the electron, then all the energy that photon has is given to the electron. So, and if this energy is it's enough, good, like large enough to make the electron removed or overcome the binding energy that it has in its structure, then the electron will reach the other plate. This tells us that if we are on the case that we know that the energy of the photon is greater than the work function of the specific metal, then the number of electrons and the number of photons is the same, because you will have as many photons hitting the electrons than electrons leaving the overcoming the binding energy and reaching the other plate. Okay, so now from here we can find that the kinetic energy of the electron will be equal to the energy of the photon minus the work function that this particular metal has. Based on Planck's theory, or Planck's explanation of black body radiation, we can say that the energy of the photon is h times f minus work function, again, is h times fo. And then the kinetic energy of the electron will be hf minus fo. So now they are not specifying in which, or we are not specifying in which unit we need it. Do we need kinetic energy? Usually it is in joules, because we have kinetic energy usually is in joules times 10 to the power of negative 34. So we will use Planck's constant as joules times seconds times 7.22 times 10 to the power of 14 minus 5.0 times 10 to the power of 14. And we will see now, based on our calculation, what is this. And I have the kinetic energy of the electron as 1.47 times 10 to the power of negative 19 joules. And if they are looking for electron volts, then you multiply it by 1.60 times 10 to the power of negative 19, and you will have in electron volts as whatever is the value. Okay. So again, the relationship that photons and electrons have is a 1-to-1. If you know the number of electrons, then you know the number of photons, or if you know the number of photons, then you know the number of electrons. Okay, this is in terms of the photoelectric effect. Now, I will close it, and then we'll do a second video for photoelectric effect, which deals with stopping voltage and the graphing that photoelectric effect has.